Hello to everyone. We are going to talk about wheel cinematic constraints. We are group number 3, and we are made up of Luis Cordova, Mario Viteri, and my person, Byron Mota. In mobile robots, we analyze the main wheel types. First, we have fixed standard wheel. Second, we have steering standard wheel. And third, we have caster wheel. All wheels share key assumptions. The wheel plane remains vertical. There is a single round contact point, and pure rolling occurs with no slip, and wheels are not deformable on our horizontal plane. This assumption leads to fundamental constraints that govern the wheel motion. First, we have the rolling constraints that ensure that the motion along the wheel plane is contained by approaching wheel rotation for pure rolling. Second, we have the no lateral slippage constraint that requires that the motion perpendicular to the wheel plane must be zero. The wheel cannot slide sideways.
Well, the fixed standard wheel has some characteristic. First of all, is that this type of wheel has no vertical axis of rotation. As a result, the angle to chassis with regard to the wheel is fixed, and the motion is limited to back and forth along the wheel plane. Also, the rolling constraint has the requirement that all motion of the wheel plane must be accompanied by the appropriate amount of wheel spin, and the sliding constraint demands that the orthogonal component to the wheel plane must be zero. We can see the mathematical expression in this place and a diagram right here. Then we have the steering standard wheel. It has the characteristic that adds a degree of freedom, allowing the rotation around vertical axis. Therefore, the angle beta is no longer constant, but essentially, the instantaneous motion constraint will not be effective. We can see below here the mathematical expression. It is the same for this type and for the fixed standard wheel.
I'm Mario Viteri, and I'll present the caster wheel. It has some key characteristics. The first one is that it can steer around vertical axis offset from the ground contact point. There's an additional parameter D that it's the offset distance. Contact point is at position B. Also, we have two mathematical constraints. The first one is rolling, that it prevents slipping in the same direction of the roll, and the second one is sliding, that it prevents sliding. Then we have some key takeaways. Two constraints apply to all wheels. Fixed wheels have constrained orientation. Caster wheels have offset steering axis, adding complexity to the sliding constraint. Constraint determine robot mobility and maneuverability. And understanding constraints is essential for motion and control and path planning. Thank you.